Hi, Assalamualaikum warahmatullahi wabarakatuh. So in this video, I'm going to respond to some of the questions asked in the forum platform. So we start off with this problem of how to solve this quadratic expression. Right, before we start off, I understand that some of you might not be very clear as when to introduce square root and so on. So now we are going to focus on a simple statement first. What if I say that x squared is equal to 81? Okay, x squared is equal to 81. Now, in this case, if I want to find what x is, I need to introduce square root. So I'm going to introduce square root on the left-hand side and the right-hand side. So now, when I introduce square root, don't forget the plus minus sign. So now, x is equal to plus minus 9 because square root of 81 is 9. Now, in other words, we're saying that x can have, there are two answers to x, where x can be 9 or x can be negative 9. Intuitively, I'm sure you can see that if you look at this statement, it is very clear that in order to get 81, there are two ways of doing it. Either you have negative 9 squared, which is equals to 81, or you can have 9 squared, which is also equals to 81. And therefore, in order to find what x is, you need to consider these two possible scenarios. So that's why you never leave this behind. You should have this plus minus sign. Now, what happens if you have something that is written in this manner? X squared is equal to 9 squared. What is x? So in this case, x will be equal to 9. Because you can see this simply by comparing. You have exponent 2, you have exponent 2. So this is 9. And if you don't know what x is, x clearly must be 9 because the left hand side must equal to the right hand side. So in this case, x must be equal to 9. So you don't need to consider in the manner of, plus minus 9. So if we go back to this problem, I think it's easy if you view it in terms of, comparing the left hand side and the right hand side. You can see that this is exponent 2, this is exponent 2, this is 9, therefore a minus 16 must be equal to 9. So as simple as that, a minus 16 must be equal to 9, therefore a must be equal to 9, which is 25. And if you substitute into this, you can say that, okay, 25 minus 16 square is equal to, 25 minus 16 is 9 square. So this is the left hand side, and clearly left hand side is equal to right hand side. So again, the answer for this question is A is equal to 9. Now, what if I write the problem statement in terms a minus 16 square is equal to 81. So clearly you don't know how 81 comes in the first place. It could be from 9 square, it could be from negative 9 square. So you need to put consideration into these two scenarios. So therefore, when you want to solve this problem, it will be by introducing the square root. So now I'm going to introduce the square root, a minus 16 square. So the same thing should be introduced on the right hand side with plus and minus sign. Next, I will have a minus 16 is equal to plus minus 9. Therefore, a is equal to 16 plus minus 9, which is essentially saying that a must be equal to 16 plus 9, which is 25, or it is also possible that a must be 16 minus 9, So 16 minus 9 is 7. Okay, so these are two possible values. Now of course when you check your solution, so check your solution, check. So let's say a is 7, so 7 minus 16 square is negative 9 square is 81. So 81 is the same as what you have here is the same as the right hand side, so the solution is correct. The same thing with this one, you can substitute 25 into a, so you will have what, 25 minus 16 square, so this is 9 square, this is also 81, so you get the left hand side equals to the right hand side, so both of the solutions must be correct. So I hope that is clear to you guys. All right, next, completing the square. There are a lot of issues and questions asked regarding this method, and a lot of students are still confused with it. And there is one interesting question or maybe statement made by the students that are saying the method seen in high school is easier, and that it's different than what I have taught you guys. So this brings to this question: is the method seen in chapter 5, which I taught you previously, is it really different than what you have seen in school? So that is a question that I would like to address today. And for illustration, I'm going to consider this question 12H from exercises 5.5. Okay, so how do I solve this question? Okay, so first of all, we have this quadratic equation. So I'm going to divide the whole expression here with 4 because I need to get rid of the coefficient of x squared here. So if I divide the whole thing with 4, the right hand side must also divide it with 4. So now I can have the following expression, which is x squared plus 8 divided with 4 is 2x minus 9 over 4, which is equal to 0 over 4 is 0. So this is the expression that I got. So now I'm going to transfer this that has got nothing to do with x. So x squared plus 2x minus 9 over 4 plus 9 over 4. So this will be 9 over 4 here. Okay. So I am left with these terms. So I'm left with this term, and I need to express these terms in a complete square. So this is why we call it completing the square method. So now what I have next is, okay, I'm going to write down in terms of blue notation. So now I have x squared plus 2x. So I have x squared plus 2x, and in order to write it, I need to write it in terms of this one. That looks like this: x plus a number, which is whatever number here, p, square is equal to q. So I need to have this form. I need to transform what I have here into x plus a number and square it. So the trick that I have mentioned to you guys is to consider expressing x plus, this is a square, you take this number here, so this is the number here that you take, and you divide it with 2. So 2 over 2, so this is the number, this is 2, so put it here, 2 over 2. So that is x plus 1 square. So can I replace x plus 1 square in this position, in this place? I cannot simply do that, because if I expand this expression, I will get x squared plus 2x plus 1. Whereas the original expression is only x squared plus 2x. So I have additional term that is not there in the original expression. So what I need to do is, in order to make sure that the original expression here is retained, I'm going to have to minus 1. So when I'm going to introduce this one, minus 1, because minus 1 plus 1, then you can cancel this out, so it will look like the original expression. Therefore, I will have to write x plus 1 square, which is this one, x plus 1 square, which is this one, and you have this one. This is similar. X plus 1 square is similar to this one, but I have to introduce minus 1 because the original one doesn't have plus 1 over here. So I'm going to introduce minus 1 is equal to 9 over 4. Now, what I'm going to do next is I'm just going to solve it like normal. So I'm going to solve it like normal now, like what you normally do. So I'm going to continue solving it. So now, x plus 1 square minus 1 is equal to 9 over 4. So x plus 1 square is 1 plus 9 over 4. So 1 plus 9 over 4, 4 over 4 plus 9 over 4 is 13 over 4. So now I need to find x. How do I find x? I can find x by introducing the square root. So I'm going to introduce the square root here. So when I introduce the square root here, don't forget plus and minus sign. So now I have x plus 1 is equal to plus minus 13 over 4. Therefore, x must be negative 1 plus minus 13 over 4. So this is the answer. So if you look at this method 2, completing the square, which I have taught you in the previous section, divide the quadratic equation with a. Okay, you have this, you divide with a. So this is what I do in the first part. So this is the first step. Okay, this is what I did. Next, move the term c over a to the right side of the equation. So this is this one. I move to the right side of the equation. So this is the second step. Complete the square on the left side so that it looks like this. So this is the third step. So and balance it by adding the same value to the right side of the equation. So this is the third step that I do. I make sure that this guy that I have looks like something with x plus p, a number, x plus p square, but I have to introduce negative 1 because again, like I said earlier, if I only have x plus 1 square, if I expand this, it becomes x squared plus 2x plus 1. Do I have x squared plus 2x plus 1? No, I don't have it here. So if I simply replace this into this position, it is not correct anymore. So how do we correct it? Of course, by having minus 1, introducing something that makes it correct. So if I introduce negative 1 plus 1 here will be cancelled. So I have what it looks like, the original expression here, x squared plus 2x. Okay, so that's why I have x plus 1 square minus 1 is equal to 9 over 4. And then after this, it is very smooth. You can just continue solving it like normally that you do. Now that brings to the question of whether what you've seen here is different than what you have learned in school. So this is what you have learned in school, according to the formula given by one of your friends in the forum. So this is what you have, the quadratic equation, and you divide with a. So this is what I do. You divide with a. It's the same thing, right? Next, this is what happens when you remove this to the left hand side. So right hand side, I'm sorry. So you remove that to the right hand side. This is what you got. So this part here is step 2. Okay. Next, you are taking so now you have b over a. B over a here is this value. B over a is 8 over 4. So this value. So b over a is 2. So this is b over a. This is actually your b over a. B over a. B over a. And you divide it with 2. So see, this is b over a. I divided with 2. And I square it. and I introduce the same thing, b over 2a square. Why do you think they are introducing this external term? Because like I said earlier, if you expand this, if you only write it, if you only write this x plus 1 square, when you expand it, it gives you something that is not originally there, because original expression is just this one, x squared plus 2x. If you expand x plus 1 square, you will get additional term here, plus 1, which is not originally there. That's why they have to minus b over 2a square. Okay, so and after that you just solve it like you normally do. So this is actually a similar thing that you have seen in school and what you are doing here in this course. It's just that I'm not asking you to memorize all this formula, because when you think of it, it is quite logical why you need to introduce -1. For example, why you're introducing -1, because like I said, you expand this, you get, when you expand x plus 1 square, you get x square plus 2x plus 1. So it is not, this one is not similar to original x square plus 2x, because there is this plus 1 that is not originally there. So how do we get rid of this? By -1. So that's why we have -1, so that the whole thing here, that you have here is exactly similar to original expression. You can only replace the term, the item, if they exactly similar. So I hope you get the idea of completing the square method. Okay, now these are the question asked by one of your friends. A ball is thrown upwards from a rooftop 80 meters above the ground. It will reach a maximum vertical height and then fall back to the ground. So the height of the ball from the ground at time t is given by this equation. So this is time, t refers to time, and h is the height. Okay, so what is the height reached by the ball after 1 second? So this is just simply substituting 1 into t. So now h is the height that you don't know. So you're going to substitute 1 into t. 64 1 plus 80. So then continue doing it. So you will have this is equal to -16, and then you will have plus 64, and then you will have this equal to plus 80, and then the answer will be, this will be equal to 128 meter. This is in meter. Next, well, how long will it take before hitting the ground? So hitting the ground means the distance must be 0, h must be 0. So you don't know how long does it take, so you don't know what t is. So -16 t squared plus 64t plus 80 is equal to 0. So this requires you solving a quadratic equation, and of course I can rewrite that so that it becomes similar to 16t squared minus 64t minus 80 is equal to 0. You can see that you can factor some of the values, so you can factor out maybe 16. So if you factor out 16, this will become t squared minus, so 64 over 16 is 40. So 80 over 16 is 5. So 5 is equal to 0. Therefore t squared, it can be simplified to t squared minus 40 minus 5 is equal to 0. And I think this can be easily solved using factorization by inspecting, the quadratic equation. So how do we do that? So how do you get t squared? T squared can be obtained if I have t and I multiply that, I will get t squared. Now I need to find what are the factors of 5. Obviously, the factors of 5 is 5 and 1. So if I multiply that, I will get 5. But I know that the sign has to be negative, so never mind, we deal with that later. So now this is diagonal multiplication. 1 times t could be t, 5 times t is 5t. So I know that I need to do something. I need to add these two terms in order to get negative 4t in the middle. So how do we get negative 4t? So I can get it if this is negative 5 and this is t. So negative 5t plus t, I'll get negative 4t. So I know that one of this sign must be positive and one of this sign must be negative. So now I need to have this sign to be negative. T times negative 5 is negative 5t. 1 times t is t. So by adding that, I get negative 40, and negative 5 times 1, I will get negative 5. So I will get this one. So it looks all right now. So I'm going to write down as this thing equals to t negative 5 times t plus 1 is equal to 0. So therefore, t minus 5 equals to 0, and t must be equal to 5 seconds. Next, t plus 1 must be 0, t must be negative 1, but this is not the solution because time cannot be negative. So obviously the answer is t is equal to 5. Okay, so in exercise question 14, E and G. Okay, so I'm going to show you question E first. Alright, so we have two parts of inequality. I can solve this part first, and then later I will consider solving the second part of it. Okay, so now let's start with the first part. So what I have here is I can rewrite it in terms of 3 minus 5w over 2 greater than or equal to negative 1. So 3 minus 5w greater than negative 2, negative 5w greater than negative 2 minus 3. Therefore, w, I'm going to divide with a negative 5, a negative number. So when I divide this with negative number, the sign should be reversed. So it will be less than negative 5 minus negative 5. Therefore, w less than or equal to 1. Now let's look at the second part. 3 minus 5w over 2 less than or equal to 9. 3 minus 5w less than 18 minus 5w less than 18 minus 3. Therefore, again, I'm going to divide that with a negative number, negative 5. So w greater than, reverse the sign. 18 minus 3 is 15 divided with negative 5. So w greater than or equal to negative 3. And of course, you can write it in terms of interval notation. W must be greater than or equal to negative 3, which means square bracket, negative 3, and less than or equal to 1, so square bracket. Okay. So next, question G. So what is this? It must be greater than or equal to 0. So for w minus 1 must be negative 1 is greater than 0. So what you have to do is, first I can rearrange that so that it looks like this. This is equal to 4w minus 1 to the power of 1, yeah? Okay, greater than 0. Now I can see that in order to have that greater than 0, I have to have either the combination of negative value times over negative value, so I will get the answer positive, or I can have that positive and positive. So positive and positive will become positive, which is greater than 0. So in this case, I know 1 is already a positive value. That means the denominator must be positive. In other words, the denominator, which is 4w minus 1, must be greater than 0. Why it cannot be 0? Because if this is 0, then it becomes undefined. If it is negative, that means the whole thing will not be greater than 0. So now, I know that in order for this expression to fit this inequality, 4w minus 1 must also be greater than 0. Okay? Therefore, 4w greater than 1, w must be greater than 1 over 4. So, that's the answer to this question. Alright, okay, next is question 16. Amar and Ishan play in the same football team. Last Saturday, Ishan scored 3 more goals than Amar, but together they scored less than 9 goals. So I can say that E represents Ishan's score and A represents Amar's score. So last Saturday, Ishan scored 3 more goals than Amar. So Ishan's score is Amar's score plus 3. Obviously from this statement, okay, Ishan's score is equal to Amar's score plus 3 more goals than that. But together they scored less than 9. So together that means E plus A less than 9. So this is statement 1, this is statement 2. So what are the possible number of goals Ishan scored? So now I can substitute 1 into 2. So I'm going to replace Ishan here with A plus 3. So now I have A plus 3 plus A must be less than 9. I'm going to know what is Amar's score. So 2A is equal to 9 minus 3, 6. A must be 6 over 2 is 3. So that means Amar's score is less than 3. That means if I can write it down in simple terms, Amar may score 2 goals or 1 goal or don't score at all. Yep, because less than 3. So he can score 2 goals or 1 goal or doesn't score at all. So this is Amar's score. Okay, possible because we don't know what is the true score. So we cannot stop at that point because now it is asking for the possible number of goals that Ishan can score. So we know that Ishan score more than 3 goals than Amar. So that means if Amar score 2, Ishan will score 5. If Amar score 1, Ishan will score 4. And if Amar score 0, Ishan will score 3. So the answer to this question is Ishan's score will be 5, 4 and 3. So this is the final answer. Okay, I think that's all. Thank you very much. Okay.